For problem 2, we're looking at the electric force that is associated between two protons, and we can treat the protons as charged particles, so we can say that the electric force between them is given by Coulomb's law, which states that the electric force is the constant K product of the charges divided by the distance between them. So imagine you have Q1 and Q2, and they're separated by some distance R12. Then the law, Coulomb's law, is the magnitude of this force is given by this equation, where this is going to be a repulsive force if Q1 and Q2 are the same charge, or attractive if they're opposite. So since we're looking at two protons, we know that they're going to be a repulsive force. The value of the constant K is 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. The charge of a proton is equivalent to that of an electron, but it's positive in magnitude. And since we have two protons, they both have the same exact charge on them, divided by the radius between them, and we're told that the distance between them is 4 times 10 to the negative 15 meters. If we multiply these numbers out, we get about 14 newtons if we do take into consideration the significant figures. And in part B, we're asked, what is the gravitational force between them? Since a proton has mass, then there's a gravitational force between two protons. And if you recall, the gravitational force is given by G, which is the Newton gravitational constant, the mass of each particle divided by the distance between them squared. And G is 6.67 times 10 to the minus 11th Newton meter squared per kilogram squared. The mass of a proton is 1.67 times 10 to the minus 27th kilogram. So we would write that times itself, divided by, again, the distance between them is 4 times 10 to the minus 15th meters squared. And I forgot to square it up here, but the answer is correct. I just forgot to write it down. And do this, and you get 1.2 times 10 to the minus 35th Newton. And you notice that relative to the electric force, the gravitational force is much, much, much smaller. So anytime the gravitational force exists with any of the other fundamental forces, like the electromagnetic force or the nuclear forces, it is tend to be ignored because it doesn't contribute that much.